It appears I ran out of time on the previous video. Anyway, the two standard deviation rule is simply you take the mean right here, 18.1, and you subtract two standard deviations from it to get the lower number, and you take the same mean and add two standard deviations to get the upper number, okay? So are there any outliers based on the two standard deviation rule? And the answer is, again, yes, because I just see one. 38 is higher than 29, so that's it. So it's the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation for your upper and lower for the two standard deviation rule. Okay, not going to go over anything you know how to do, but just two things that are new here that we haven't seen yet. The mode is simply what appears the most in the data. What set of data appears the most in the data? So 3.2 appears twice. There's no other data that appears more than once. So the mode would be 3.2. Okay? All right. Now, interestingly, let's just say I added one more piece of data. Let's say I added 1.9 to this data. Well, then there would be two modes. You would answer 3.2, 1.9. So there could be more than one mode. If it's a tie for anything that appears the most, you just list them both. And if I even, this is one more, one for the heck of it, 1.8. So it's a three-way tie. So you would just list the modes are 3.2, 1.9, and 1.8. And there could also be the situation where you, let's get rid of all these and X that out, just say that it didn't exist. Then there's nothing that appears more than once, so that would be none. Okay, but for this problem, the answer is obviously 3.2. So it could be none, could be one of, could be two, could be three. I mean, it just depends. But I think for the purposes of this course, I don't think you'll find any more than one, but I just wanted to let you know in case it did come up. And the range is simply the highest minus the lowest. So what's the highest in here? 3.6, I think, right? No, 4. I see a 4. So 4 minus the lowest. What's the lowest? 1.8. Okay, which is what, 2.2? I did the math right in my head. So that's all it is. Okay. Okay, what is standard deviation? Just forget about this problem for now. Just take a look at what I put here. These two sets of data, they're both average of 14. If I take these scores, add them up, and divide by 5, which is what mean or average. Mean and average are the same thing. If I take all the test scores, add them up, or any data, whatever it is, if I take the data, add them up, and divide by the number of data, you total these up, you get 70 divided by 5 is 14. You notice that this has the same average. You total them up, you get 70. You divide by 5, you get 14. But you'll notice that all these are close, very close to the average of 14, 10, 12, 15, 17, 16. They're all pretty darn close to 14. However, this data is kind of like, the mean is still 14, but the data is more kind of all over the place. So this data is going to have a smaller, the more closely that the data is to the mean, the smaller the standard deviation. The more data that it is apart from the mean, the higher the standard deviation. So in some problem in the future, I'll show you how to do it by hand, but I'll tell you how to do both the mean and standard deviation with Excel. So again, use formulas. You're going to use this all semester long, so drill this right in your head. You're going to find the mean and standard deviation all day, every day for the rest of the semester using Excel, okay? So more functions, statistical, use average for mean, okay? And then just highlight the data. Boom, okay, 14, all right? For standard deviation, let's say this is a sample, and that's important. I'll tell you in a minute why. Say these are both samples, okay? You would go formulas. Now pick, oh, by the way, pick a cell that's not near the data, like over on the side. You can't pick something like here or here because it's going to calculate it. That goes for anything. That even last thing that I forgot to mention about the quartiles. Pick a cell away from the data Okay, formulas. You go to more functions, statistical, stdev.s. Okay, stdev.s for sample. If it were a population, you would use this one. For sample, use this one. Most of the time, in fact, almost all of the time this entire semester, and there are some exceptions, but very few, but you will know, trust me, you will know what you have to use, and most of the time you'll be using this one, standard deviation.s, and again, just highlight that, okay? All right, so the standard deviation for this data is pretty small, 2.9. Now watch, this one's going to be bigger. Now we can do the same thing. Let's do average just to make sure, I put in the data right for one, okay? Oops, that's not what I wanted. Okay, formulas, more functions, statistical, average. You can slide this over. You could just grab it. If it's in the way like it is right now, I'm glad this came up actually. Just click it and drag it over, okay? You could do that, all right? And then hit OK. All right, I did enter it right, okay? 14. And watch, this standard deviation is going to be higher. More functions, statistical, stdev.s. And again, get used to this. Drill this into your head, make notes. This is not the only chapter you're going to use average and standard deviation, okay? See that? A lot bigger. So in other words, a lot more variance of this data than there is this set of data, even though the means are exactly the same, okay? Okay, if you can, you could copy and paste. Now, I could copy and paste this data here over to my spreadsheet. There are certain instances you will be able to do that, and there are certain instances you won't be able to do that. If you can't do it, you just have to type it in yourself, okay? But this will save you a minute. You could plug it in anywhere. I could plug it there. Doesn't matter, okay? All right. And it could be in a column too. It doesn't matter. If you could copy and paste it into the spreadsheet, try it. If not, you're just going to have to manually type these data points in, okay? So the sample mean, again, this is a sample. This is data from a sample. So the sample mean, again, it's formulas. You could go to another thing too. Well, first of all, when this thing is not, like I have this in a smaller version, it's very difficult to go in and you can't find what we did before. You have to expand it way out, okay, to get formulas and everything I was looking for. However, if you have it condensed, there's a nice tool you could use, formulas recently used, right over here, okay? If you've just used it in the past, you don't have to expand it and find it. You could just go to recently used, which obviously we have, quartile X, median, quartile, so average, all right? So, and then again, you just click and drag it over here if it's in the way, okay? So there's my sample mean, okay? Rounded, that's 2 decimal places, as they say. That's important. This entire course, again, this entirety course, you have to know how to do rounding. 2 places, 26.077. That means you round 2 places, it's 26.08. If you have any questions on how to round, please make sure you ask somebody, ask me. I get you the right help. You need to know how to round correctly for this course, or you will be doomed. I promise you. The entire course, start to finish, you will be doomed. All right. The sample standard deviation. Again, we're going to go to formulas, recently used, stdev.s. And if you haven't recently used it, you have to expand it and do it like we did before a minute ago. And again, it's just highlight the data. Okay, there's the standard deviation of the sample. And again, rounded to 2 places is 9.61. Now the variance, all the variance is you can do it on your calculator, is this squared. Okay, the standard deviation squared. So 9.61 squared, or 9.61 times 9.61, if you will. 92.35. Okay, all you do is take the sample standard deviation and square it. And now you discover that the data was from a population. Remember I mentioned in the prior little bit ago that if it's a population, again, it's very few times this chapter, but if it is a population, then now we have to expand here because we haven't used that yet. Formulas, more functions, statistical, stdev.p, there it is, P, and then highlight the data, enter, okay? So as you see, the standard deviation does vary whether it's a sample 9.61 or population 9.06. All right, this question will make you think. Think about it. If I have a list of data, it doesn't matter um, what the actual data is. Like if they're all scrunched together with a small standard deviation, or if they're all over the place with a big standard deviation, that's not going to affect the mean, or the median rather, which obviously then it's not going to affect the median. The number that's in the middle will be in the middle, whether they're all scrunched around that median average or not, and the IQR is going to be the same thing. Now, what will be affected is the mean, because if you got all these extreme observations, that will affect the mean because you're going to add them up and divide by the number of data and the standard deviation. So those are that problem will make you think a little bit. So the mean and the standard deviation is affected by skewed data or a bunch of data all over the place, whereas the median and the IQR will not be affected at all. I want you to listen to what I have to say for the next 30 seconds or so, and stop and pause and write this down, because this will be important the entire semester. You're going to be using these guidelines. Symbols, okay? Population sample. For me, the symbol for population it's a Greek symbol. I don't know what it is. You'll see it if you see it up here eventually. Looks like a U with little extended legs. And for a sample, it's X bar, okay? For standard deviation, another Greek symbol, it looks like an O with a little loop on it. Okay, that's the standard deviation for a population. For a sample, it's just a small s. Number of data points, like right here, the number of data points in this data is 1, 2, 3, 4, 5. There's 5 data points. So if that were a population, that would be big N, and if that were a sample, that would be the sample size small n. In other words, say I wanted to get the average of all the test scores in my class, okay? That's the population. I'm going to define the population as all 30 students in my class. I would take all the test scores, add them up by the number n, which is 30, and divide by that number, and that's my that would be my average. So n would be the total number of students in my statistics class. If I was lazy and just wanted to grab a sample of 10 students in that class, then I would take those 10 students, divide by n, small n, and that would be the sample size, because we're using it for a sample. So small n is the sample. In other words, another data point is n regardless, big N, small n. Each individual data value, regardless of whether it's population or sample, is x. So 15 is an x value. 2 is an x value, okay? 6 is an x value. 6 is an x value, and 15 is an x value. Okay, so the only time you're going to calculate standard deviation by hand, and any time for this entire semester, will be this chapter right now. So we just want to show you how to do it. The course requires that you learn how to do this. After this chapter, you could use the answer. You could use Excel to check your answer. You could do whatever you want, but we do want you to know how to do, at least have an exposure how to do this by hand. So here's the 5 data points. These are each x values, as you see. X values: 15, 2, 6, 6, 15. Okay, the first thing you do is find the mean. We know how to do that. Not going to go over that. Okay, the next step is to take each x value and subtract the mean from it. Okay, so 15 minus, once you find this mean, you're going to subtract it from every x value. 15 minus 8.8, you get 6.2 right here. 2 minus 8.8, negative 6.8 here. 6 minus 8.8, negative 2.8, and so on. Okay, then the next step is you're going to take each one of these numbers and square it. So this number is 6.2 squared, okay, to get 38.44. This is negative 6.8, square it, you get 46.24. Do yourself a favor. Anytime you know that a negative number as squared is going to be a positive number. So you notice all these are positive numbers. You cannot square a number and get a negative number. So make your life easy and just put like 6.8 times 6.8. Ignore the negative sign, okay? Because you're going to get a positive every time. 2.8 times 2.8, or 2.8 squared on your calculator, you're going to get a positive. 2.8 squared, 7.84. Okay, 6.2 squared, 38.44. So in other words, no matter what the sign is, just enter it as a positive in your calculator. That way there's no way you could screw it up. Then the next step is to take all these numbers that you just squared and add them up to get 138.8, okay? All right? So a couple more steps after this. because it's a